Hey, what's up guys? We're back, and in this video, we're experimenting with bottled oxygen in a can of Pringles. Now before we jump into this crazy mad science, I've noticed a lot of comments about how dirty my lab jacket has become. And in my opinion, a dirty lab jacket is just a token of how much knowledge and experience we've been able to gain. But to answer your request, let's go ahead and get that changed. And there we have it, problem solved. Let's dive right in. Now you probably remember a few videos ago, we took a propane bottle, snipped the tip, and turned it upside down to extract liquid propane. Do you think the same method would work with a bottle of oxygen? Could we extract liquid oxygen? So quick update guys, I got my modified nozzle off the propane torch, but when we try adding it to the oxygen, the threads don't match, which means we can't screw it on and we can't use it to extract the oxygen. So we're gonna have to try something a little bit different. And if you look down in the mouth of the bottle, you can see there's a little button in there, and if you use something small enough and press that button down, you get the oxygen to release. The other thing that I noticed is as we shake the bottle around, I can't hear any liquid sloshing around, which doesn't give me much confidence there's much in this bottle at all. And if we look at the side of the bottle, you can see it's only 1.4 ounces, which really isn't a lot. So why then are these bottles of oxygen $11? $11 for an ounce and a half. Come on guys. But just for the sake of experimenting, let's go ahead and flip these things over and see what we can get out. All right, our Allen wrench is set in position, our bottle's upside down. Theoretically, we release the gas, and if it cools down enough, we should get liquid oxygen. Here we go. Oh my gosh, there we go, 10 seconds. My pliers are barely even frosted. My Allen wrench has a little bit of frost on it, but there was absolutely no liquid. So this thing is completely empty now. I can press that button and it's completely depressurized. There's no more oxygen. 10 seconds and nothing satisfying about that. That was $11, completely vaporized. So for our next experiment, what would happen if we soaked one of these bottles in liquid nitrogen first? If we were to bring the temperature down so cold and bring the oxygen that's already in there down to a liquid, perhaps then we could get it to drip out. Let's see if it works. All right, it's time to chill it up. Let's get this canister completely submerged. Here we go. I'm just gonna do this nice and slowly because I don't want that nitrogen to boil out the top. Look at the way it jumps. It's jumping like a good 2 inches high there from all the heat that it's extracting. I'm listening to the container and I can hear things contracting in there. I can hear it cooling down. I love these little drops of nitrogen that spit out, leave little smoke trails. We're getting the boil, that's a good sign. The storm before the calm. And we just hit the bottom. That's as far down as I can go right there. The boiling nitrogen makes a really cool noise. I just love the way that it sounds. All right, so we are completely submerged. We're just gonna chill here for about 30 to 40 seconds. And right there you can see the nitrogen's gone relatively calm, which means most of the heat's been extracted. So go ahead and make your predictions below. Now that our oxygen is cooled down to the temperature of liquid nitrogen, if I turn it upside down and press the button, will we in fact extract liquid oxygen? Check this out, the canister's changed color. It used to be like a really bright red, and now it's more like an orange. That's kind of interesting. It's a pretty stark contrast in the color there. All right, moment of truth. I'm not really sure how to do this. I've just got a death grip with my pliers around the neck here. I'm gonna pull it out, use the Allen wrench to get up there and press the button, and we'll see if we can get any oxygen out. That looks really cold. Very, very cool. Drip off the nitrogen, press the button, and here's what we get. It's actually so cold right now, the button is barely even releasing. I do see some liquid dropping out there. Do you see that? We just have a couple little drops. Yeah, there it is. Look at that. We are, in fact, getting liquid oxygen. It's not much. If I hold it up here, maybe you could see it better. I think that's about all we're gonna get. This bottle is completely empty now, but check it out. We did manage to get a little bit of liquid oxygen. Come look at this. Right down there in the bottom, boiling away, is a little bit of what I think is liquid oxygen. And it's gone. Okay, so that was a little anticlimactic. So yes, apparently theoretically it is possible to extract liquid oxygen from one of these canisters. However, for $11 of oxygen and the cost of liquid nitrogen, we got such a little amount, I don't even know if that was worth it. So for this last experiment, I'm going to show you the method that I love to use the most for making liquid oxygen because it's very cheap, very economical, and you certainly get a lot more than an ounce and a half. So what exactly do we need to generate liquid oxygen? Well, surprisingly, the only materials we're going to need are a canister of liquid nitrogen and some styrofoam cups. Now go ahead and grab yourself a styrofoam cup. In this case, I'm using 8 just to speed the process. We're going to lay them all out across the counter. Now that we got our styrofoam laid out on the counter, we're going to take our liquid nitrogen and fill each of them up individually to the top. Then we're pretty much just going to step back and let them sit for 25 minutes. Styrofoam acts as a really good insulator, so we don't lose nearly as much nitrogen filling these up as we would with any other container. And the best part of this nitrogen is it's all homemade. There we go. All of our styrofoam cups are completely filled up to the brim. They couldn't go any more or they'd be overflowing. All we have to do at this point now is simply step back and let them sit for about 25 minutes. Quick update guys, it has been an hour we've been letting this nitrogen just sit here, and what's been happening is it's been taking the oxygen out of the air and condensing it, and that oxygen's dripped down to the bottom and stayed there until the nitrogen's boiled off. You can see each of these containers have reduced to about 1/8 of their original volume, and if you look really closely, you'll notice that the liquid has turned blue. That blue liquid, my friends, is liquid oxygen, and now if we take all 8 of these cups and dump them together, we get 1 full styrofoam cup of liquid oxygen. Very, very cool stuff. The other thing that's really interesting is how frosty these cups get. You can see all the different layers where they've actually taken the moisture in the atmosphere and condensed it to the side. Watch this, if I just tap these cups gently, all the snow falls off. Fun! Pretty blue oxygen, man. Guys, look how beautiful that is. Not only do we have a full cup of liquid oxygen, we actually have a little bit left over as well. It's almost like what we would hope to see if we added blue food coloring to liquid nitrogen and it actually worked. But this here is very natural. Oxygen in its liquid state is blue, and it's also paramagnetic. Check this out. If we take something like a strong neodymium magnet and hold it near the liquid, look what happens. The liquid jumps up onto the magnet and sticks to it. How crazy is that? Liquid oxygen responds to a magnet, at least until it burns off. There's quite a bit of it on there. And I can't get it off, it's stuck. That's cool. Now I do have to mention guys that liquid oxygen, unlike liquid nitrogen, is a very, very volatile substance if it comes in contact with a fuel. Liquid nitrogen is not flammable, it puts out fires. But if you add a fuel to liquid oxygen and light it off, the results can be explosive. So here's what I'm thinking guys, what do you think would happen if we popped a pack of Pringles, soaked one of the chips in liquid oxygen, and then lit it off? Shall we find out? All right, so we're gonna move our oxygen over here. We're gonna dip this chip until it gets very, very cold. And what I'm hoping is happening is it's infusing with oxygen. I've never tried this before, so I'm not really sure what to expect. All right, that should be enough. See if I can fish that out. Not easy, there we go. All right, got my flame going, let's light it off. It's not nearly as fast as I was expecting. Oh, and now look, it stopped burning. It was kind of like fizzling and popping and going quite quickly, and now it's slowing down. So let's pour a little bit of oxygen on it. Oh yeah, we can get it to reignite. Look at that. Slide that chip right toward the oxygen. Wow! Do you see that when the oxygen makes contact, it almost explodes every time it touches? Look at this oxygen here. It's just skittling around. It's got the same similar properties to liquid nitrogen, the Leidenfrost effect. Watch what happens if I tap it. And it goes into 1,000,000 pieces. And then these chips just randomly spark up. That's cool. All right, let's try that again. Let's get one of these chips soaking, but the oxygen burns off a little too quickly, so what I'm gonna do is pour a little bit of oxygen into the plate as well before we actually light it off. Okay, there's our chip. We're gonna set that right there and light it off. More oxygen. Oh yes, that's very vigorous. Oh wow, look at all these pieces of Pringle floating around. I got black blobs of Pringle filling the entire airspace above my head. That's kind of nasty. And finally, let's just do the styrofoam cup itself. There it goes. Oh my goodness, look at the ceiling. Oh, that was a bad idea. So there you have it, guys. That was incredible. And now you know how to use liquid nitrogen and styrofoam cups to make liquid oxygen right out of the air. We started off filling up 8 cups with liquid nitrogen right to the top, then let them sit for about an hour until all the nitrogen had boiled off. But in the process of the nitrogen boiling off, the oxygen in the atmosphere condensed and was sucked into the cups. And when we mixed all 8 of those cups together, we had a cup overflowing of blue liquid oxygen, which apparently is paramagnetic. Just keep in mind that liquid oxygen can be very, very dangerous stuff, and if it catches anything on fire, it can make a terrible mess. Thanks for joining me for this experiment, guys. I'll be looking for you in the next one. Talk to you then. That was unexpected. That got frosty, didn't it? Whew. It's a cryo container. Freezing my fingers. Looks very cool.